All right, how's everyone doing?
Good. How are you?
I'm doing well, thank you. All right, let's talk about ODP 418 because there were a bunch of issues with that string processing. So remember the goal was to make this function called move that takes the first character, puts it in the last spot, and shoves everything down one spot. And here's code similar to what I saw from some people. We save the first character in a temporary variable called save, conveniently. We loop through and we copy from character I+1 in the input to character I in the output. That's moving things down one spot. And then we check to make sure our string's not empty, and we put that save character in the last position, and we tack on a null terminator. And we have test code that takes ABCDE and passes that to move, and the result is put in a variable called out, and we print that output. And if we compile this up, and we run it, I forgot to prototype my function, we run it and it looks fine. Right, ABCDE turned into BCDEA. And so lots of emails coming in last night saying, my code works great, but I'm not getting 10 out of 10 when I assess, I'm getting a 0. So remember when I described this, I said there's 3 cases you need to worry about. There's the general case, okay, which is ABCDE. There's the edge case where the string is empty, and there's the edge case where the string has 1 character in it. If you want to be really safe, make another case where you have 2 characters. But since we're moving things down and we're moving the first thing to the last, something that's really short is going to be kind of edgy, right? We've got a for loop here, and if you don't do something like this, right, if you have an empty string, I-1 might be -1, right, and you might get a segfault here and so on. So that was one thing, was making sure you test all those cases. The second thing I said is make sure that you're not assuming anything about the initial values of things that you don't declare. So for example, the output array, we declare it to be an array of 100 characters, but we don't give it a value. And so my suggestion was fill that with question marks. Okay, so let's do that. So I'm going to use string copy, and I'm just going to load a bunch of question marks into here, just to give it some interesting known value to begin with. And now I'm going to compile this, and I'm going to run it, and suddenly you see that there's a problem with your code. ABCDE turned into BCDEA question mark. Right? And a good bet that question mark came because we loaded question marks in there to begin with. If you're really not sure, right, we could make a bunch of Z's and try that, and now it's pretty much undeniable, right? That last character is something that was already in out to begin with. So what's going on with this? Well, get a piece of paper, set your input equal to ABCDE null terminator, set your output to a bunch of Z's. I has no known value, so it's a question mark. Save is equal to the first character, so that's an A. And now go through your for loop, and I will be 0, 1, 2, 3, and 4. And when you finish this for loop, I will be 5. And when you get down to this last statement here where you say out bracket I+1 equals null, that's going to say out bracket 6 equals null. Well, what's been happening, you've been building up your output array. So this takes time. You have to do this by hand, right? But this is going to be B, C, D, E, A, and the rest were all question marks. And I is equal to 5. So if I is bigger than 0, out bracket I-1 equals save, right? So I is 5, out bracket 4 is right here. That got written to be save, so that's correct. But then your last statement says out bracket I+1 equals null terminator, right? Well, I is equal to 5. This says out bracket 6 is the null terminator. Well, this is bracket 0, 1, 2, 3, 4, 5. This is out bracket 6. So that gets replaced with a null terminator. And what is your final output string? B, C, D, E, A, whatever happened to be in that 6th element, and then the null terminator. That's your problem. So you look at it more and you say, well, I really wanted the null terminator to go right here. That's out bracket 5. How did I know I should put it in out bracket 5? Well, I was equal to 5 after my for loop. So think through the logic along that line and say, you know what? I'll bet this should have been, ignore all of this. I bet this I plus 1 should have been an I. So do that, try it, run it. Now your code looks better. But the way to get there, one way to get there is by, like I say, pretend you're a computer and give your variables interesting values if they don't have initial values. Integer I, set I to a question mark or set it to negative 5 million or something obscure, right? Don't just assume it's a 0. Actually pick a value and give it a value and write it down. Otherwise, you know, when you get down to where you use I, your brain's just going to say, oh, that's a 0. And it might not be. That might be what's tripping up your code. If you don't have this if statement, if you just say this and you realize that you've never done your for loop, I still has a value of question mark, and now you say out bracket I minus 1 equals save. Well, we don't know what the value of I is. Right? So this business of looking at your code on paper and stepping through it as if you're the computer can reveal all kinds of potential issues. Does that make some sense? Okay, so we're going away from strings for a while, and we're playing with something else. If we have a network connection. We don't have a network connection. All right, so take a look at ODP 419 online, but I'll tell you what the deal is. So you're making a pair of functions called put and get. So put takes an integer and it saves it somewhere. Where is up to you. But put should take an integer and it's an argument and just save it somewhere. And it should return 0. I don't know why. I just wanted it to return 0. So it always returns a 0. Okay, you have a second function called get. Get does not take anything as an argument, but it returns an integer. What integer does it return? Whatever the value was that you used when you called put. So put is just taking an argument as an integer and it just throws it in the box. And get just looks in the box, sees what value is there, and returns that value to you. That's all it does. That's all that's going on with put and get. Okay? Very, very simple operation. If you know what stacks are, this is not a stack. If I call put 500 times, the last value that I put in the box, that's what get returns. And if I call get 500 times, it's always going to return that same value. There's no deeper memory going on. Put just takes the argument, saves it somewhere. Get just returns that value that's saved. So you're supposed to put these in a file called putget.c. And the question is, how do we do this? How do we save the value of this variable so that we can retrieve it later? So let me give you some skeleton code here. Here's your integer put. Integer n, and it does some stuff. And here's your integer get, which takes no arguments, and it does some stuff, and eventually it returns something which should be the number that you saved. All right. When we have a function like this, any variables that we declare between this curly bracket and that curly bracket, they're local. They're local to this function put. And when we exit this function put, those variables basically go away. Their values are effectively lost. Any variables we declare between these two curly brackets are local to the function get. And we can set them, we can read them, we can modify them, but once we exit this function, those values are essentially gone. So if we put a variable in here and we copy n to that variable, once our put function returns, that value is lost. So we need something like a global variable. And the trick is, if we declare a variable outside of these functions, then it has more permanence. It basically will continue to exist. And if we declare it before our first function, it will still be available inside all these other functions. So we can do something like this, integer save. And now I can access save inside here, and as long as I don't declare a local variable save inside this function, if I say save, it's referring to this variable. And in my get function, as long as I don't say integer save somewhere inside here, if I just say save, it's going to refer to that same variable. So the whole trick to making put get work, put just copy n into save. Save equals n, and get just return save.
So what if you do declare a variable with the same name in the function?
If you declare a variable with the same name in a function, then save means that local variable. And it's not an error, and you won't get any warnings or issues like that, but if I try to give a value to save, it's not going to be that global one. And sometimes that's the right thing to do. Yeah?
Is this ever, like, would you ever do this in your own code where you have a separate function to save an integer to a global variable, or would you just, like, do it in main?
It's actually cleaner to do it like this, because if I do this in main, then everywhere in my main program I got to remember, don't use the word save, don't use the word save, right? It's global throughout the whole thing, and that's kind of considered bad form. I've heard stories of teachers threatening to, like, take off massive points for that. But here, you know, this is just one dedicated function, and you might not even have the source code for this. This might just be a library that you link with. So it keeps it kind of cleaner. And it ties into something that we'll talk about in Java in 2.23 in spring when we talk about accessors and mutators, fancy sounding words. But you could do it in main. It would be the same. Yeah?
So if you had main above that, then you couldn't use save within main.
Correct, right.
Okay.
Maybe you could in some versions of the compiler. But let's say no. And in the ODP, right, you're going to write the put get function and you're going to link it with the test bed. So you're linking it with ODP 419 main.o from /temp. So it definitely doesn't have direct access to save. All right, so clear on intended behavior and how to use a global to make that work? It's not much more code than this, right? It's a few more lines of C. Again, the trick is just sort of getting all the details nailed down just the right way, right? So it's practice at dealing with these globals and passing and returning, and make sure that put returns a 0, because I think I checked for that. I think we lost our network. All right. All right, so that's 419. So PA4. I think we already talked about this using the less than sign. Did we talk about this with respect to War and Peace? So your index program, PA4, always reads from standard in. You don't have to use fopen, you don't have to use fclose, that kind of stuff for reading from files. Just read from standard in. But if you want to test your code with input coming from a file, you can type your program name, less than sign, name of the file, and now standard in comes from that file instead of your keyboard. So your code is just reading standard in, right? if you're just say file name, it thinks it's reading what you're typing on the keyboard. But if you say index less than file name, now standard in is coming from the contents of that file. But your code, it's the same as if you were typing it. But you don't want to type in War and Peace to test your code. So this is called input redirection. We're going to talk more about this in hopefully a few days. Okay, so this takes us up to getChar. And I suggested yesterday, don't try to use fgets for PA4. Because fgets reads an entire line of text, and that line might contain 5.5 phrases. Right? It might contain 5 phrases separated by commas, and then part of another phrase that continues on the next line. And trying to take that apart and then put it back together in the right way is going to be really, really unpleasant, right? The easier way to do PA4 is to read your input one character at a time. Okay, and this is what getChar is for, and this is why we're talking about super duper getChar. So read your input one character at a time, and think about it like this, okay? So you're your PA4 program. What's a day in your life? You wake up, and you say, give me a character, and it reads the first character of input. And it's the beginning of a phrase. Okay, so you stick that somewhere in memory. You say, give me another character, put that next to the first one. Give me another character, put that next to the second one. Do that a bunch of times, and now you come to a comma. Okay, so you say, give me a character, and you got a comma. Okay, you've seen a complete phrase now, because commas end phrases. So you take all these characters you've been saving, you throw a null terminator on the end. You know how to do that. You've been doing that for days, weeks. And now you've got a phrase. Here's my phrase. And you hand that to the dictionary code. And you say, do something with this. And your dictionary code says, well, this is a new phrase. I'm going to save it and record that you've seen it once. Or it says, oh, I've seen this phrase 5 times already. I'm going to update that and say I've seen this 6 times. Right? Now it's back to you. Okay? Give me a character. Here's a space. Okay, we're waiting for the start of a phrase. Here's another space. Here's another space. Here's something that's not a space. Okay, this is the start of a new phrase, so save that first letter. Give me another character, save that one. Give me another character, save that one. Get to a terminator, a period. Got a phrase, throw an null terminator on it. Here's my next phrase. Give it to the dictionary code. That's your life. That's all your program has to do, right? There's lots of details to that all. But that's basically what it's doing. It's ingesting a character at a time, building up phrases. When it finds a phrase, hand it to some code that updates the dictionary accordingly. And then read characters until you get to the start of a new phrase. And if you say, give me a character, and it hits the end of the file, you say, I'm done, no more phrases. Take the dictionary, pass it to the sort and print routine, and then you can exit. Go back to sleep. So let's look at this business of reading characters from standard in one character at a time. And so the function we're interested in is called getChar. And the manual page is a little weird because it says getChar is equivalent to getC standard in, and getC is equivalent to fgetC. So let's see what fgetC says. It reads the next character from stream while stream is standard in, and returns it as an unsigned char cast to an int or EOF on end of file or error. Okay, too many words. So let's just write some code. Let's see what getChar does. Okay, so first thing, getChar returns an integer. Okay, this is important. It's called getChar. You would think it gets a character, right? But it doesn't. It returns an int. And there's a good reason for that, which we'll see in a few minutes. So if I'm going to say the return from getChar in a variable, it's got to be an integer variable. So I'm going to call it integer C. And let's just call getChar. So here's a little bit of test code. C is an integer, set getChar's return value save that in the variable C, and then let's just print out the value of C. Get car return the integer, and we'll print %d with the value of C. So let's run that, and let's say hello, and it tells me get car return the integer 72. Okay, so what's your best guess? What's significant about the value of 72?
Is that capital H?
That's capital H. It's the ASCII code for an uppercase H. So I tell people, if you want to remember one ASCII code, remember uppercase A is 65. Because from that you can count up to other letters because they're just incremental. So B will be 66, C will be 67. Fingers and toes, you can get all the way up to T. So that's a handy one to know. And then if you add 32, you get to the lowercase letters. So lowercase a is 32 beyond that, so that starts off at 97. But yeah, so that's an uppercase H, 72. And this other stuff that I typed didn't seem to matter. It only looked at the first character, which was a 72. All right, what will it return if I just hit enter?
The ASCII key for ASCII code for the \0.
\n.
Yeah.
Yeah, so ASCII code for a new line.
Yeah.
So it returns a 10. So 10 is the letter J is the 10th letter of the alphabet. Character code 10 corresponds to a control J, which is actually the ASCII code for a new line, for no particular reason. But if I hit Control J, it looks like I'm just hitting enter. That's a new line. All right, now I've said a few times, if you want to signal the end of a file, the end of your input from the keyboard, you use Control D. Right? It's just a code that says end of input. So it's calling get car right now. It's waiting for something to appear. I'm going to hold down Control and press D. It tells me get car returned -1. -1 is not a legal ASCII code. ASCII codes start at 0, they run through 127. This is not an ASCII code. This has nothing normally to do with Control D. Technically, Control D has an ASCII code of 4 because it's the 4th letter of the alphabet. What's happening here is just something that's an understanding. When getCar detects end of file, instead of returning an ASCII code for a character, it returns the value -1. It's a flag, basically. And when we see -1 coming in, we say, oh, that's not an ASCII code for a character. That means end of file. And we know that there's no more input available. So if I run my go function, and let's see, let's make some file. So here's a file called file, and it contains hello. If I say go less than file, it tells me it returned integer 72. Why? Because the first thing it read from the file was the uppercase letter H. Now if I run go, and I feed it an empty file, like /dev/null, it returns -1. There's not a -1 in dev null. Dev null is empty, but the first call to getCar said, hey, I'm already at the end of the file, and so getCar returned -1. So 2 lessons so far. 1, getCar always returns an integer, and you got to treat it like an integer. Okay. 2, you got to check that integer value and make sure that it's not end of file. And let's see if I can like just mess up everything I've just said. What happens if we make C a character? Right, so if I type hello, it still returns a 72. If I do a Control D, yeah, okay, so that still works. But don't do a character, do an integer. We got lucky. Sometimes it'll actually come out as 255, which will ruin your day quickly. All right, so next lesson. It says fgetC returns an unsigned character cast to an integer, or EOF. Okay, EOF is really the correct way to check for end of file. -1 is a magic number. We don't like magic numbers. So let's see what EOF is equal to. How? I'm just going to print the value of EOF with a %d. So let's try that. Guess what? EOF is equal to -1. So we can use -1, we can use EOF. Use EOF. Okay, why? Because if you wake up on an alien world, their EOF might be -17. And if your code says if it returns -1, your code's not going to work. But if your code checks for EOF uppercase, it's guaranteed to be whatever end of file is set to, right? Whatever getCar is going to return.
You make the argument that it's more readable too.
It's more readable too, yeah, because you don't have to wonder what the heck is this -1. So if you look inside standard.io.h, there's a define statement. Define EOF to parentheses -1. And we talked about the preprocessor the other day. So if I run go_to through the preprocessor to get rid of all of those includes and defines, here's the actual code. Printf EOF equals %d \n close quote comma, and there's what it actually uses instead of EOF. Alright, so here's the right way to check for end of file. Let's put this on the other side. So we'll get a character. If it's end of file, we'll say so. And let's return. Otherwise, we'll print out the value from getCar. So hello gives us 72. If I hit Control D, it tells me end of file detected.
And so, to get like phrases and stuff like that, you just throw that in a loop.
Basically, yeah. So let's put this in a loop and let's see what it does. So how do we loop? C equals getCar. Bless you. So let's loop while C is not equal to end of file. So while C is not end of file, let's go ahead and print out the character that getCar got. And let's read another character. And then when we hit end of file, we should kick out of this loop, and we'll just print a message saying end of file detected. So call getCar once, and while it's not end of file, print out its value, get the next character, and just keep looping. So if I say hello and I hit enter, I see the ASCII codes for HELLO and the ASCII code for the new line, which is 10. And it's sitting here. A, B, C, D, X, Y, Z. There's some ASCII codes and a new line at the end. And then if I hit Control D, end of file detected.
And so for the PA4, we just throw that into a super duper getCar.
Yeah.
Store that in a string and
Yep.
test it against the other string.
We're going to start building super duper getCar in a few minutes.
So why is it that it only starts reading through standard in when you hit the enter
Good question. It's almost like I was about to talk about that. So here's the thing. Imagine the sort of pipeline that we can think of as being standard in. Okay, it's a pipe that you can push things in one end and pull things out from the other end. When you call getCar, it basically looks at this end of the pipe. Okay, things travel in this direction. Basically looks at the pipe to see if there's anything in there to read. And initially the pipe's empty, so getCar does what we call block. It just kind of sits there and it doesn't do anything. It's waiting for stuff to appear in here. Okay, so I'm sitting on the keyboard and I type A, B, C, and none of that goes into this pipe, right? If I run my program and I type A, B, C, none of that is available for getCar yet. Why? Because I might change my mind. I might go back and type X12, or I might go back and change that to X10, right? And until I hit enter, I'm just kind of like typing on this line right here. None of that's actually going into this pipeline. Okay, once I hit enter, so I did X10. So now there's an X, a 1, a 0, and a new line. And now getCar says, hey, there's something in there for me. It grabs that X and it returns it. And if I call getCar again, it will pick up that 1 and return it. If I call getCar a third time, it'll return the 0, and a fourth time, it'll return the new line. And the fifth time I call getCar, it sees an empty pipe. So I hit enter, and my first 4 calls to getCar came back finally. And now I'm inside another call to getCar. But there's nothing in that pipeline until I type some stuff and hit enter. And then all of that goes in the pipe. And in this case, since I'm calling getCar in a loop, it just keeps reading from there until the pipe's empty. So this is called a blocking read. This will be important in the end of spring, so try to remember it for 30 weeks. No. It's a blocking read. When you call getCar, if there's nothing available to read, you sit inside that function call, right? And this is just sitting here. I'm inside a call to getCar, and my program's kind of stuck until something becomes available. And then if you hit Control D, a signal is sent to getCar that says you're not going to find anything in the pipe, go ahead and return EOF. And my code picks that up. So here's my program Go. So I'm looking at a process status on my laptop. So there's a process being run by Nick. It's process ID 13629. It's executing the command Go. This middle part here is a state. It's in this state called wait_W. It's waiting for input. Right? It's just kind of hanging out with nothing to do. If it's actually doing something, like PS, right? My state is a dash. That means it's running. So it's just kind of hanging out waiting for more stuff. And then if I hit Control D, my while loop kicks out because C was not different from EOF, and it gives me a message and the file detected. So we can make this a little more interesting. Instead of printing ASCII codes, because now we know what the ASCII code is, let's print out the character C as a character with %C. So %S gives you a string, right? You got to pass it an array of characters. %D shows the value of an integer. %C shows you the value of a single character. Even though C is an integer, it'll print as a single character with %C. So what happens if I run this? Right, so it just shows me my input. And then Control D says end the file. So I can run this on its source code. Let's take go.c and feed that in place of standard in. And there's a copy of the program being printed out by the program. At the end it says end the file detected. The other way that we can monkey with standard in is by using this pipe, which we're also going to talk about more in a little bit. We can say command 1, pipe into command 2, and now the output of this becomes the input of that. Right, so we played with this a few weeks ago. So I can say cow say hello, and I get my talking cow. If I type that and I pipe that into my Go program, instead of reading standard in from the keyboard, it'll read it from the output of cow say. And so there's the output of my Go program, including the message and the file detected. Goodbye.
You just string a ton of C programs together like that.
Yeah, you can. I should have done something different here. I'm just going to do this because it'll freak you out in a good way. Let's go back to returning an integer, to printing out an integer value. Okay, so we're back to that. So if we run cow say and we put that into Go 2, you know, it's a bunch of spaces mostly, with a few characters thrown in. If we do cow say hello, put it into LOLCat, we get the rainbow version, right? What happens if we put that into Go 2?
The same output.
Oh, that's disappointing.
Because isn't lolcat just prepending a bunch of color codes?
Yeah, I was looking for the color codes. This is more complex than I wanted. All right, forget that. Bad demo. So there's a less interesting demo, but I hit the up arrow key 5 times, right? And it showed me that getCar returned 27, 91, 65, 27, 91, 65, 27, 91, 65. When you hit an up arrow, there's no ASCII code for an up arrow, right? An up arrow on your keyboard actually generates 3 keystrokes. What's called an escape, that's ASCII code 27, and then a left bracket 91, and then an A is 65. If you hit a down arrow, that's an escape bracket B. And a left arrow is escape bracket D, and a right arrow is escape bracket C. It's just a trick that's being used because we only have a few ASCII codes, 127 of them.
And doesn't backspace do something to something?
Backspace is usually a character 8, but my shell's going to eat it and just take it as a delete. But backspace would be ASCII code 8, and delete is actually 127, but that also gets eaten by things.
Sometimes when I use, I think fgets or something,
Mhm.
try and backspace that, it spits it out.
Yeah, yeah. All right. So let's see. Let's go back to Go. Okay, so Go is reading standard in and one character at a time and printing it out. So let's make super duper getCar. Let's start it. So super duper getCar, the idea is it's just like getCar, but it's better, right? So what does it do? Well, one thing it does is it converts all of the letters from lowercase to uppercase. It also changes all white space into a single space, and it gets rid of the characters we want to ignore, the quotation marks, the dashes, and so on. So let's start that. Let's make our own version of getCar. So super duper getCar. So I'm going to prototype it up there. I'm going to write it down here. And we'll call it in here. C equals super duper get car. Okay, well that's not terribly super duper, right? That's just get car. But let's try this anyway, because we got a lot of code here. A lot of things could go wrong. Okay, so let's just run it on a source code again, and it seems to work fine. We didn't break anything. We just didn't really add a lot to get car. Okay, let's just make this new version of get car do the uppercase conversion, because that's one of our 3 requirements in the beginning. And the magic function you want to look at is toUpper. So toUpper comes from ctype.h, and it takes an integer and it returns an integer. These functions convert lowercase letters to uppercase and vice versa. If C is a lowercase letter, toUpper returns its uppercase equivalent, if available, which it is in ASCII. Otherwise, it just returns the original C. Okay, so toUpper does not change C. It takes an input and it returns a function value, which is the uppercase version. So to use this, we need to do something like, new equals toUpper old. So let's try that. Let's make a better C. So we'll call C equals get car. So that's the original. And this will be the uppercase version, better C. And then let's return better C. So we added a couple of lines of code to this. And we need to include ctype.h. So let's go, let's feed it hello. There's the uppercase version of hello. Here's a bunch of lowercase stuff. There's the uppercase. Here's some mixed case. Converts it to uppercase. And Control D, it still says end of file detected. So if I run that on its source code, what do I get? It shouts my source code back at me. And things that aren't letters, they don't get disturbed. Semicolons are still semicolons, but any lowercase letters got changed into uppercase. EOF, which was already uppercase, is unchanged. So this toUpper function is really useful. All right, never, 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 unless you feel like it, look at ASCII codes to do case conversion. Right, so you can look at the ASCII code, and if it's between 65 and 96, you can add 32 to it, and so on and so forth. Don't do that, okay? Most people will take off lots of points for that. And again, wake up on a foreign world and they use a different coding system, that code may not work. But guaranteed toUpper will work, whatever they're using to encode text. So, and toUpper works for non-Arabic letters. So this is the start of super duper get car, right? You get to use it just like get car. We didn't have to change our main program at all. It just always gives us back an uppercase letter. So let's keep going. So the second requirement was anytime you got any kind of white space, space, tab, new line, vertical, form feed, any of those, you want to change it to a space. And here your friend is space. So isSpace is one of a number of helper functions, also available from ctype.h. And isSpace will tell you if you have white space. So it checks for white space characters. So space, form feed, new line, carriage return, horizontal tab, vertical tab. And these things return an int, and so we can use them inside an if statement. So if is space better C, so if it's some kind of space, what do we want to do?
Nothing.
Change it to a space. So if it happens to be a tab, it'll become a space. If it happens to be a new line, it'll become a space.
Will this catch multiple spaces?
No, and you're not required to, right? So the phrase generator will deal with that.
Gotcha.
All right, and then we still return better C. All right, so it's not clear what's happening here because I'm also typing while it's running, but let's run this on its source code. And what happened? All of my new lines got changed into spaces. My tabs in the beginning of statements got, well, I don't have tabs in here. If I had tabs, they would be changed into spaces. And this all came out as one line. And at the very end, the last new line right here, after the closing curly bracket, got changed into a space, and then that was followed by our message saying, end of file detected. All right, last thing I want to mention on here. EOF is still a special case, right? If we hit the end of the file, we want to return EOF. Well, that seems to be working, but if we want to be really sure about this, we could do something like this. That turns out to be unnecessary, but if it helps you be more relaxed, I recommend putting that in. Because here we're very clearly saying we're going to call getCar. We know getCar might return EOF when we hit the end of the file. First thing we're going to do, if it's returning EOF from getCar, let's just return that from SuperDuper getCar. And now SuperDuper getCar really looks exactly like getCar, except letters get turned into uppercase and any kind of white space gets turned into a space. All right, well, you only got one more thing to add to this and you're done with this part of the assignment, which is if you get those characters you're supposed to ignore, we should ignore them. We shouldn't return a double quote or a single quote and so on. So we'll flowchart that tomorrow and we'll play around with some code. And then, you know, we've got this new version that's a drop-in replacement for getCar, but that does a big chunk of our pre-processing for us.
Can I see the is space button?
See the what? Oh, yeah.
This is part of the source code.
Yeah. So if better C is a space, we just change it to a single space.
Thank you.
Yeah. All right, so we'll keep going with this tomorrow.
And we don't have to worry about multiple spaces.
You're